The B-pillar is dead. China just destroyed the rules of physics for more than 100 years. Every single car on the road has shared one quiet, unglamorous secret. It's not the engine. It's not the wheels. It's a thick steel column hiding between your front and rear doors, and you've probably never thought about it once in your life. That's the B-pillar. And engineers will tell you it's one of the most important pieces of metal in your entire vehicle. It's the backbone that keeps the roof from caving in during a rollover, the anchor point for your seatbelt, and the wall that stands between your ribs and the front end of the car that just slammed into your door. For a century, nobody dared touch it. Then China looked at it and basically said, "Cute pillar, but we're getting rid of it." Before you assume this is some flimsy gimmick, you need to understand why the B-pillar exists in the first place. Picture a side impact crash test. A car the size of a small truck slams into the door of your vehicle at highway speed. Without a B-pillar, that door has nothing holding it rigid against the frame. No spine, no resistance. The whole side of the car folds inward like a soda can, and that energy has nowhere to go except straight into the people sitting there. Regulators in every major market, from the IIHS in America to Euro NCAP in Europe, build entire crash test protocols specifically targeting this zone of the car. The B-pillar isn't decoration. It's the difference between walking away from a T-bone collision and not walking away at all. Automakers have tried to get rid of it before, and almost every attempt has ended the same way: compromise, controversy, or quiet cancellation. Rear-hinged suicide doors go all the way back to horse-drawn carriages, and they made a real comeback in cars like the Mazda RX-8 and the Honda Element, both of which used clever front and rear opposing doors to create one giant cabin opening with no pillar in between. It looked incredible. It felt like the future. And then the safety data came in. The Honda Element took a beating in side impact testing specifically because of that missing structural pillar, and one by one, these pillarless experiments got quietly discontinued. The BMW i3 kept a half-door version of the idea alive for a while. Rolls-Royce solved the problem the expensive way by keeping a B-pillar but disguising rear-hinged coach doors around it, which still leaves you with a tall slab of steel standing right where you want to climb in. For 100 years, you could have wide-open doors, or you could have safety, but you couldn't have both. That was just how it worked. That was physics being physics. It's worth remembering that rear-hinged doors actually got their nickname for a genuinely terrifying reason. Back when seatbelts weren't standard equipment, a rear-hinged door that popped open at speed would catch the wind and fling itself wide open instead of slamming shut, and the unlucky passenger leaning out to grab the handle could get pulled straight out of the moving car. Gangsters in the 1930s reportedly loved them for exactly that reason. So when modern engineers talk about reviving the suicide door concept, they're not just chasing a cool look, they're wrestling with nearly a century of safety baggage attached to the idea. Rolls-Royce calls its version coach doors, specifically to distance itself from that history. But underneath the polite branding, every one of those vehicles still carries a full B-pillar to keep regulators happy. Then Zeekr, the premium electric brand owned by Geely, rolled out a minivan called the Mix and immediately set off alarm bells across the internet for doing the unthinkable, building a passenger car with absolutely no visible B-pillar at all on either side. Full stop. The Mix uses double sliding doors on the passenger side and a single conventional door for the driver, and when those sliding doors retract, they leave behind a single uninterrupted opening 1.5 meters wide. That's wide enough, as Zeekr's own marketing cheekily pointed out, to walk livestock through. Combine that with a floor height of under 400 millimeters, and you've got a cabin that a toddler or an elderly grandparent can step into without any climbing, ducking, or awkward shuffling around a steel post. It looks like a concept car that escaped from a motor show and somehow ended up legally registered for the road. Naturally, the internet's first reaction was suspicion. Surely this thing folds like a tin can in a side impact. Surely this is style over substance. Here's where the actual engineering trick comes in. and it's a genuinely clever piece of lateral thinking. Zeekr didn't delete the B-pillar, they relocated it. Instead of one fixed steel column welded into the body between the doors, the mix hides two separate ultra-high-strength steel pillars, each roughly 70 millimeters thick, built directly into the structure of the doors themselves. When you close both sliding doors, those two hidden columns line up and effectively recreate a B-pillar made of two interlocking halves, sitting exactly where the real one used to be, except now it disappears the instant you open the doors. Think of it less like removing a support beam from a house, and more like swapping a single fixed wall for two doors that snap together into a wall only when you need one. The car gets its rigidity back the moment everything's shut, and gives it up entirely the moment you want to climb in. The materials involved are where this stops being a cute party trick and starts becoming a genuine engineering flex. Those hidden pillars are forged from steel, rated at 2,000 megapascals of tensile strength, using a reinforced hot-forming process that Zeekr claims pushes strength more than 30% beyond standard hot-formed steel, which is already some of the toughest material used in modern car bodies. Zeekr says each pillar can withstand roughly 20 tons of load. Pair that with a one-piece die-cast rear body section borrowed from Zeekr's larger 009 minivan, and you end up with a shell that the company claims hits a torsional rigidity figure of around 37,600 Newton-meters per degree. For context, a BMW X5, a vehicle built the conventional way with a full fixed B-pillar, comes in at roughly 31,700 Newton-meters per degree. On paper, the car with no visible pillar is stiffer than the German benchmark SUV that has one running right down its side. And Zeekr didn't just publish numbers and hope nobody asked questions. They staged the crash tests publicly, the kind of stunt that's either supreme confidence or a very expensive way to be embarrassed. A mobile barrier was sent into the side of the mix at 60 kilometers per hour, the classic side impact scenario that doomed the Honda Element and its pillarless cousins decades earlier. Then, just to make a point, they dropped a 2.2-ton shipping container straight down onto the roof, simulating the kind of crush load a rollover puts on the structure. According to Zeekr's account of the test, the body held its shape, didn't deform, and the driver's conventional door opened normally afterward, as if nothing had happened. Whether you take an automaker's own promotional crash footage with a grain of salt is fair, but the engineering logic behind why it should work checks out, and that's the part worth paying attention to. None of this engineering gymnastics happened by accident either. Zeekr wasn't just chasing a wider doorway for its own sake. The mix was built around a cabin concept, where the front seats rotate up to 270 degrees to face the rear passengers, turning the interior into something closer to a living room on wheels than a traditional minivan. Zeekr's own executives described the idea as making face-to-face the default way a family experiences the car, complete with a sliding center console that doubles as a table or a mini fridge. That kind of layout only works if getting in and out doesn't involve squeezing past a steel post planted right where you'd want to swing your legs around. The missing B-pillar wasn't the goal. It was the obstacle standing between the engineers and the cabin experience they actually wanted to build, which is arguably why they were willing to spend so much money solving it, instead of quietly giving up like everyone before them. What makes this story even more interesting is what it cost to get there. Zeekr's own executives have been refreshingly blunt about the price of this innovation. The development resources poured into the mix reportedly ran about 2.8 times what a typical mid-size SUV costs to engineer, making it, by Geely's own admission, the most demanding project in nearly 30 years of the company building cars. The electric sliding doors alone, according to a Zeekr vice president, needed more than 400 million yuan in dedicated development spending, and the manufacturing cost of each door reportedly runs 5 times higher than a normal car door. This wasn't a cheap shortcut or a clever marketing illusion bolted onto an existing platform. It was a from-scratch redesign of how a car's entire side structure thinks about strength, and it apparently cost a fortune to make work. Step back and look at the bigger picture, and this stops being a story about one quirky minivan and starts looking like a preview of where car design is headed. For decades, the B-pillar sat there as an accepted, unquestioned cost of doing business, the price you paid for surviving a crash. China's EV makers, flush with battery and manufacturing expertise and racing each other for headlines in an absolutely brutal domestic market, are now treating unquestionable automotive assumptions as just another problem to engineer around. Other manufacturers have started circling the same idea. There have been reports that Genesis is working through how to build coach door vehicles without sacrificing crash performance, suggesting this isn't going to stay a uniquely Chinese curiosity for very long. If hidden, modular pillars built into doors prove out over years of real-world use, rather than just staged demonstrations, you could be looking at the next big shift in how every minivan, SUV, and family hauler gets built. The same way unibody construction, or crumple zones, once rewrote the rulebook. So did China actually break the rules of physics? Not exactly. And that's honestly the more satisfying answer. Physics didn't bend. Engineers just got smart enough to stop treating the B-pillar as a fixed object and started treating it as a function, a job that needs doing, not a specific piece of metal that has to sit in one specific place all the time. The mix doesn't eliminate structural support. It just makes that support modular, foldable, and invisible until the exact second you actually need it. That's not magic, and it's not a loophole. It's just really, really good engineering, wrapped in a marketing headline designed to make you stop scrolling. And judging by how many videos and articles are already arguing about it, it's working.